Okay, chapter 4. Let's see, problem number 2. They give us negative 3x plus y is equal to 8, and they give us negative x plus 2y is equal to negative 9. So here's what chapter 4, the first couple sections, are all about. Try and figure out the x and y that make both of these statements true. And then they're going to teach you different techniques. So right now, the first thing they want to show you is that if we plug in certain values, will it work? So for part A, they give us negative 5 and negative 7. Remember, that would be our x and our y. And they're wondering if we plug negative 5 in for x and negative 7 in for y into both of these, will it be true? And then the other question, well, let's just try that. So negative 3, x is negative 5, plus y is negative 7. Does that equal 8? That's positive 15. Negative times negative is positive. 15 minus 7 is 8. Okay, that holds true. And now let's try the second. So basically, we're trying to find the x and y that holds true for both. It held true for the first one. Let's try the second one. So negative x, negative 5, plus 2, y is negative 7. Does that equal negative 9? So that's 5 minus 14. Does that equal negative 9? 5 minus 14 is negative 9. So negative 9 equals negative 9. So yes. So A, that is a solution. So the game is they give you two algebraic equations, and they say, hey, try and find the x and y that make them both true. So negative 5 for x, negative 7 for y works, so we call that a solution. Okay, so in part B, they say, hey, why don't you see if negative 5 comma 7 is a solution? Okay, so let's try it again. Well, we know negative 5 positive 7. Okay, so let's plug it in. So negative 3, negative 5 for x, plus 7 equals 8. 15, negative times negative is positive, plus 7. Does that equal 8? Does 22 equal 8? No. So this is not a solution. Okay. So how to figure out the x and the y that will make both of these true? There's a couple ways to do that. Let's see. I asked you to go in a weird order, I think. I'm trying to pull it up right now. Chapter 4. Okay. So then, okay. Well, here's one way to do it. It'll make sense. So if you have x and y stuff in a number, this is just a line. X, y, number, this is just a line. So if we think of things as lines, then the solution is where the lines cross. So let us try number 8. Okay. Y is equal to x minus 2, and y is equal to negative 3x plus 2. So we're trying to figure out the x and y that might make both of them true. And what they say is, hey, here's a way to solve that little riddle by graphing them. Now, graphing is a really bad idea because unless you have graph paper and the numbers are really pretty, it just doesn't work well. But let's graph this guy. Y equals x minus 2. Go to negative 2, put a dot. Slope of 1, up 1 over 1, up 1 over 1. So it looks something like that. And then now let's graph this other one. I'll graph it in purple. Positive 2, 1, 2, put a dot. Slope of negative 3, so that's down 3 over 1, down 1, 1, 2, 3 over 1. Aha. So we can clearly see where they cross is at the location. So that location right there is over 1 and down 1. So that is the solution. Now, getting the solution by graphing is cool because you can totally visualize what's happening. But technically, the game is, hey, just find the x and the y that make both of them true. So if x is 1 and y is negative 1, both of these will be held true, like in problem number 2 that we did previously. So on a side note, notice that there's a couple situations that could happen. You could just have lines that cross, and you get one answer like we did. So this is sort of like the normal situation. Imagine, if you will, that you had lines that looked like this. So if the lines were parallel, you would get no solution. And every once in a while, so this is usually the case, is you get an answer. Every once in a while, you get a no solution. And then sometimes, this is really weird. Imagine, so I've been graphing the lines, pretend in black and pink. So imagine if one line looks like this. So solutions are where they cross, right? So if they cross in one point, you get one answer, one solution. So if the lines don't cross, you get no solution. So what if you have one line and the other line lies exactly on top of it? So then you'd have an infinite number of solutions. So there's sort of three cases. So when you have no solution, whenever you're doing the math, you'll see this later, but for right now, no solution means you get a weird false statement in the math. You'll get something like 0 equals 1, something false. If there's an infinite number of solutions, you'll get something true like 1 equals 1 or 0 equals 0, something true. Oh gosh, okay. Well, that probably made no sense, but I showed it to you anyhow. Okay. And then I think this is where it gets weird. I asked you to move, I want you to do the elimination method before the substitution method. So let's jump to like number 48. Okay, 48. 48. Now these problems, it's just a game. It's a little riddle. So we're going straight to the elimination method because the elimination is the best method. I skipped over the substitution method because that's kind of a shortcut. Okay, so the goal is to find an x and a y that make them both true. So here's the idea. Let's try and get rid of the x's or the y's. I see 2x, I see a 3x, minus 5y, minus 1. Sometimes it's better to just do the problem and then we'll try and make sense of it. Tell me if this makes sense. I'm going to multiply this line by 3 and I'm going to multiply this bottom line by a negative 2. So if I multiply this whole line by 3, it's going to turn into 6x, the 3 goes to everybody, minus 15y equals 21. And then here it's going to give me a minus 6x, minus minus, so plus 2y equals negative 34. So what I was unable to explain was my goal. I'm trying to get one of the letters to go away. So you see how I created a 6x on top of a minus 6x? So that way, when I combine the lines together, 6x and minus 6x, that goes bye-bye. Negative 15y and a positive 2y, that turns into negative 13y. And a 21 and a negative 34, that turns into a negative 13. So notice in the very beginning, I wanted to get rid of the x's or the y's. So I said, well, let me get rid of the x's. Okay, there's a 2x, there's a 3x. They both go into 6. So let me multiply this by 3 to create a 6x. And if I wanted to cancel out nicely, let me multiply this by minus 2 to create a negative 6x. Bye-bye. So coming back over here, get y alone, divide by negative 13, divide by negative 13. Y is equal to 1. So once we have that y is equal to 1, you can pick any of these. You can pick this equation or this equation. Anything with an equal sign is called an equation, equal sign equation. So let me just pick the first one, 2x minus 5y equals 7. And if y is 1, so 2x minus 5, let's let y be 1, equals 7. 2x minus 5 equals 7. Add 5 to both sides. Add 5, that gives us 12, divide by 2, divide by 2. X is 6. So our answer is, if you put it in sort of an x comma y, our answer is 6 comma 1. Okay, so we found the x and y that make both of these true, and that was the elimination method. Whew. Okay, let's try, that was 48. Let us try 50. So I got rid of the x's that time. On the next one, I'll get rid of the y's. You could get rid of either one. It doesn't matter, as you'll see. As long as you follow the rules, it'll work out. So here's 50. 3x minus 5y equals 9. 5x plus 2y equals 16. So I'm going to focus on, so right now you might be saying to yourself, oh, multiply this by 5 and this by negative 3, and we'll get rid of the x's. That works. Keep going. That means you understand what's going on. Just for fun, I'm going to get rid of the y's. Okay, there's a negative 5y, there's a positive 2y. So they both go into 10. So if I multiply the top by 2 and the bottom by 5, just double check. That's going to create a negative 10y, and that's going to create a positive 10y. Negative 10y, positive 10y will cancel. Okay, so see how I'm getting rid of the y's this time? In the previous problem, I got rid of the x's. It doesn't matter. Get rid of the x's, get rid of the y's. With practice, you'll see that sometimes it's easier to get rid of the x's, sometimes the y's. Most people just always just get rid of the x's like we did in 48. But whatever. Okay, so let me clean this up. That becomes 2 to everybody, right? Don't forget that guy. So 6x minus 10y equals negative 18. 25x plus 10y equals 5 times 16. Oh my gosh, 80. Okay, see that negative 10y over the positive 10y? That was our goal. Bye-bye. Because what I'm doing is I'm combining the two lines together. 6 and 25 is 31. 80 minus 18, I sadly need a calculator. 80, oh, it's 62. 62. Aha, I did not need a calculator. Okay, let's get x of 1, divided by 31, divided by 31. So x is 2. Great, we got x is 2. Now let's get y. So should I use this line or should I use this line? It doesn't matter. Either one will work. Let's just use the bottom one for fun. Okay. So 5x plus 2y is 16. X is 2, so let me plug that in. Okay, so that's 10 plus 2y equals 16. Subtract 10 from both sides. Subtract 10, subtract 10. Didn't show my work. You cool with that? 2y is 3. So if we put it as an ordered pair, the x is 2, the y is 3. Ta-da! Elimination method. I guess I'll do 56. Fractions. So 56, 1/3. I put the x up top. Minus y equals negative 3. X plus 5 halves. Y equals 2. Okay. So I just don't like fractions at all. So tell me, before I even attack this problem, I just want to get rid of the fractions. So this is over a 1, that's over a 1. So essentially, tell me if this trick makes sense. Let me put a bracket there so it looks different. So this isn't what we were doing before. I'm not ready to do what we were doing before yet. The first step in my mind is let's just get rid of the fractions. I don't like that there's a 1/3. So what if I multiply everything by 3? That would give me, so 3 times 1/3 just goes to 1x. 3 times a minus y, and then a 3 times a minus 3. Okay? And now let's get rid of the fractions here. So it's over 1, over 2, over 1. So over nothing means over 1, right? Over 1. So let's multiply everything by a 2. So 2 times x, 2x. 2 times a 5 halves, the other 2's cancel, plus 5y equals 2 times 2 is 4. Okay, so now we are back at what it looked like. So this looks nice. So let's do the elimination method. So now that we've done 2 problems where I got rid of x, I got rid of y, what seems easiest? Here's what seems easiest to me. Tell me if you see this. The goal is to get rid of either x's or y's. It's going to be easiest to get rid of the x's. All I need to do is multiply this whole line by a -2. You see how that's going to create a -2x, which will combine with the 2x and they'll cancel? Oh, so I didn't even have to do anything to this line. Aha! See how fast and efficient and lazy that was? So let me rewrite things. So -2x, negative, plus 6y equals negative is positive 18. And this guy I'm just going to rewrite. 2x plus 5y equals 4. Negative 2x and sitting on top of a positive 2x, because I'm just going to combine the lines together. Here's the fun part. Bye-bye. Okay. 6y and 5y is 11 of them. Equals 18 and 4 is 22. Get the y alone. Divide by 11. Divide by 11. Y is 2. Boom. We have y. Let's get x. I could plug it into this. I could plug it into this. There's fractions. There's fractions. I don't like that. I could plug it into this. I could plug it into this. This one looks the laziest, so choose that one. X minus 3y equals -9. This would have worked. This would have worked. This would have worked. This would have worked. This one seems easiest. Okay, so x minus 3, but y is 2, equals -9. X minus 6 equals -9. Add 6 to both sides. Add 6 to both sides, so x is -3. So my answer, if I write it as x comma y, would just be the x is -3, the y is 2. Whew. Okay, how long is this video? 17 minutes. Oh my gosh. Okay. Well, let me just keep going. Substitution method, world's longest video. So now that we understand elimination method, I'm going to go back, because I said to do things out of order. So elimination method always works. Now, the next thing we're going to do, we're going to go back up to, we'll do solve by substitution, number 30. So actually, it says to solve by substitution, but feel free to ignore them. Yeah. Feel free to ignore them. So right now you're looking at number 30, and you're like, well, I just want to do the elimination method. Cool. Just do elimination method. But they said to do substitution method. Yeah, who cares what they said? Ignore them. Okay, 2x plus y equals -4, 3x minus 2y, -6. So the substitution method that they want you to do is a kind of what I consider a fancy trick. So you see how there's just a y alone? So if you have one guy just kind of alone, we can rewrite this, what is that symbol? We can rewrite this top equation if I bring the minus 2x from both sides. So y is equal to minus 2x minus 4. So you see how I just subtracted 2x from both sides? So all I did was rearrange this to look like that. Okay, so y is negative 2x minus 4. So if that's what y is, why don't we plug that in right here? The substitution method is a shortcut. In this one, not so short, but generally speaking, this could save you time. Okay, so 3x minus 2, and instead of y, let's put this mess, what y really is, negative 2x minus 4, and that needs to equal -6. So that's going to be 3x minus, distribute that minus 2, so 3x minus 2 times minus 2 is plus 4x, minus 2 times minus 4, positive 8. Let's see, double check, positive 4, okay, equals -6. 3x and a 4x on the same side, that's 7x, plus 8 equals -6, that's minus 8, minus 8, 7x is equal to -14, so divide both sides by 7, x is negative 2. So if x, see how right here you're like, okay, I guess it was a little bit quicker. So substitution method. We got x, let's get y. Should we use this one? Should we use this one? It doesn't matter. This one, oh, why don't we just use this one? Okay, that makes more sense. So any of this equation, that equation, this equation, they'll all work. This one's going to be easiest. So our y is equal to negative 2. X we said was negative 2 minus 4. Y is equal to 4 minus 4, so y is 0. So if we write our answer as x comma y, it's negative 2 comma 0. Whew. Okay, and then we'll pause it. So essentially, yeah, you should be able to handle 4.1. Excellent.